With you once again. How are you doing? Once again, we are back to our physics, and remember, if you are following us or updated with our video, we're discussing about motion. And you know, motion is a very broad topic in physics, and of course, other motion we've talked about the velocity time graph, other motion we've talked about the friction, other motion we've talked about the inclined plane, another motion now we're talking about the circular aspect, which is refers to as the circular motion. So I tag it simple circular motion. But before then, there are some questions under it, which is very, very technical. And there are some little principles we have to understand before we can be able to solve questions regarding circular motion. Actually, it's a very simple aspect of motion, but if you don't understand those principles, you might find solving the questions difficult. So now, the number one, what is the circular motion? The circular motion can be refers to a speed, an object in a speed moving in a circular path. That object is exhibiting what? A circular motion. An object in a speed moving in a uniform circular path is said to exhibit what we call circular motion. And secondly, we have the parameters that are used in the circular motion. Let's assume we have a circle. Now, consider this circle. Let me refer to this. We have the internal part of this circle. Now, there are things that are actually occurring here now. Yes. Now, first of all, we have the okay. Now, at this point, there are two things happening here now. Now, let me label it from here to here, of course, to the distance point. We have the radius, and of course, there is a velocity acting. Yes, that keeps the body moving, and at this point in time, there's another velocity acting here that also changes with the direction of the body in a circular pattern. So this is radius now. Now the acceleration at this point now is the rate of the change of the velocity then to the what? To the radius. This is the acceleration of a circular motion, or we refer to it as centripetal acceleration. Now, something is happening here now. This velocity. And now, we have what we call the centripetal force. Centripetal force. Centripetal force. Then we have what we call the centrifugal force. Yes. Centrifugal force. I want you to take note of the arrow. The centripetal force actually acts in the outward part, while the centrifugal force acts in the inward part. Why centripetal force? Centripetal force is a force that is an inward force that keeps the body moving in a circular path, or that attracts the body towards the center of the circle. I repeat again. Centripetal force is an inward force that attracts the body towards the center of the circle, while centrifugal force is an outward force that tends to keep the body away from the circle. An example is when you are driving your car in a corner or in a bend, or let's assume in a circular, or they call it runabout, in a circular path. Yes, you know there is a friction between the tire of the vehicle and the ground, and at that point in time the vehicle tends to exhibit a kind of force that keeps it at that point. That force that attracts it towards the center is the what we call the centripetal force. But at the same time, again, there's another force that tends to keep the vehicle away from the circular part, of which, if the tire of the vehicle is not properly gripped to the ground, the vehicle tends to skirt and move away from the path, and that force that takes it away is what we call the centrifugal force. Examples of motion: the motion of the earth around the sun is a circular motion. The motion of the moon around the earth is a circular motion. The motion of a string, when you tie a mass on a string, is a circular path. When you are twisting it, is a circular motion. We experience circular motion in virtually every areas of our lives. Now, take note of that centripetal force. It's an inward force that keeps the body towards the center of the circle, while the centrifugal force is an outward force that keeps the body, or take the body away from the circle. And that's just the main difference. So now we have the linear acceleration. The linear acceleration is what is change the velocity square over r. Yeah, there are a lot of mathematics involved in this. I might not be able to go into it, but just have to understand that the linear acceleration is what? The v square over r, where v is what? The velocity, and r is what? Is the radius of the circle. Now, what we need to consider again is what refers to as angular velocity, because you know that this body is moving. So there is a velocity that keeps this body moving. What's the angular velocity? Angular velocity is actually the angle subtended divided by the last time. Is the angle subtended by the circle divided by the last time. So the angular velocity is represented by there's a name they call it, but this is a symbol, which is what the angular angle, the angle subtended by the circle, or the subtended angle, which is theta, to the what? To the time. Yeah, this is what we refer to as the angular velocity. Now, the angular velocity now is the acceleration, and now there's what we have linear velocity. You know, linear velocity or velocity is the rate of change of displacement or distance over time in a specific direction. So we can say linear velocity in this circular motion is s over t, where s is the distance, and t is what is the time. But then we also have what we call the radians. The radians, which actually explain this now. So there is a distance with which the angle made to the circle. That distance and the displacement in that circular direction with respect to the radius is what we refer to as what? As the radians. Yes, this is the radians. So the radians is actually the distance of the angle with respect to the radius is the radians. And now there is a relationship between the radians. This v now it has an s. So what is the s? The s, which is the distance or displacement, is what? Is the angle multiplied by the what? The radians. So this is the displacement, which is the angle multiplied by the radians now. So let's substitute it for s here now. So we have v is equal to what? Whenever you see s, put what? This theta over r. So it's going to be what? Theta r over t. Are you getting it? So theta r. So this s now is theta r. So now theta r over t. Now don't forget that our w is equal to what? Our w, which is the omega, which is the angular velocity, is what? Is theta over t. So whenever you see theta, put the angular velocity. So v is equal to, you know, theta over t is what? Our omega. So just replace theta over t with what? The omega, which is the angular velocity. So we have w or omega r. So this is the relationship between the linear velocity and the angular velocity. So the relation between the linear velocity and the angular velocity is the velocity is equal to wr. Then note that the linear velocity is distance over time. Note that the linear acceleration or centripetal acceleration is this. Then the angular velocity is this. Then you know this, and once you know this, you are good to go. Please understand this. Let me come back again. This is the centripetal acceleration. This is the angular velocity. This is normal linear velocity. This is the radius. This is distance in the circular part. This is the velocity, normal velocity, but we have substituted what? The value for the distance in the circular part. Then this relation between the velocity and the what? And the angular velocity. The relation between the linear velocity and the angular velocity is this. Now let's come back to the centripetal force now. You know, centripetal force is that inward force that keep the angle moving in a circular pattern, or the inward force. So, but then there's what we call the centrifugal force now. There's the centripetal force or centrifugal force, whichever way. Centrifugal force or centripetal force, what is the formula? You know, normally what is force? Force is what? Force is equal to what? Mass times acceleration. Are you getting it? Yes. So the centripetal force now, F, which is what? Mass times acceleration. So what is acceleration? Acceleration is what? I told the acceleration in a circular part is what? V squared over r. What is V? V is velocity, r is radius. So the force, the centripetal force or centrifugal force is what? Mass times V squared over r. So our F now at the end of the day, the centripetal force is mass V squared over r. So this is centripetal force. Let me put it this way. Now this is centripetal acceleration. Yes, acceleration in the centripetal part. And so once you know this formula, these are what you need for your circular motion. Centripetal force is what? Equal to mv squared over r. Centripetal acceleration is equal to v square over r, then you are good to go. So just take note of these formulas, and I'm telling you, um, circular motion will be very easy. So let's quickly treat this question before we go. Now, the mass of 10 kg is moving in a circular path of radius 2 meters with a uniform speed of 50 meters per second. Find the centripetal acceleration and the corresponding centripetal force. Yes. So now, what's the mass? The mass M is what? 10 kg. In a circular path of radius, the radius is what? 2 meters. In a uniform speed of 50 meters per second, that is the velocity, which is what? 50 meters per second. Find the centripetal acceleration. So, centripetal acceleration, I call it AC. Remember, let's come back to our formula, which is this: v square over r. Is the v given to us? Yes, 50. So it's going to be 50 square over what? Over r. What's r is 2. So 50 square, 5 times 5 to give us 25. So it will be 2,500, then all over 2. So 2,500 divided by 2 to give us 1,050 meter, 1,250 meter per second square. Yes. So at the end of the day now, this is the centripetal acceleration. The centripetal acceleration is what? 1,250 meter per second square. Now, what's the corresponding centripetal force now? So the centripetal force, which is Fc, what's the formula is what? mv square over r. So what is m? M is given to us as what? As 10 times what is v? And v is given to us from the question as what? 50. And square it all over what is r? R is what? 2 meters. So at the end we are going to have 10 times 50 squared to give us 2,500 all over 2. 2 year 1, 2 year 5. So 2,500 times 5 to give us 12,500. So the centripetal force is what? 12,500. So what's unit is what? Newton. So that's the answer. So I hope it's clear with you, and I hope it's straightforward. Once again, please subscribe to this channel so that you can enjoy more of our videos, and then we'll give you the like sum calculations, solutions to difficult questions, and by the grace of God, we are going to get there. Thank you. Have a nice day and stay connected. Bye.